Let's address a couple of factors that drives the planning of deliverables for any project. We have the client's KPIs. We have specific deliverables for each stage of the project. We have the required information to be able to manage the built building once it's completed. And we have technical aspect of how designers produce information that is relevant for each project stage. The KPIs is coming from the client's own business objectives, and some of the information they will need to use to manage and monitor how the project is progressing is information on how the building is clashing, or how relevant the information is to the stage of the project. If information is included that the client needs to use to be able to run analysis on cost projections and things like that. The other one is what information the facilities manager needs to be able to operate and manage the building once it's completed. And that type of information is things like warranty periods and contact details for suppliers, and day-to-day monitoring of information. For example, if we have auto closing technology on fire doors, for example. So if we have a fire door that's been left open for more than 5 minutes, it triggers an alarm and maybe sets off a release function so the doors close automatically. If those type of components are broken, the manager of the building needs to be alerted so they can address the problem and perhaps send a service call out. That information needs to be included in the 3D model at the relevant stage of the project, so the client can see that, okay, we have this type of information in the model right now, and we can use this information to project how we're going to be running the building and what the cost for that type of operation is going to be. Then we have the information that is required for each project stage, and that information should be listed out in the responsibility matrix, where we have all the components of the building listed in order, and under each component we have then a set of data that is usually outputted in the schedule, the door schedule, for example. So if we have a fire door, we need to have the dimensions of the fire door, we need to have the fire rating, we need to have the warranty period, we need to have the installation date, we need all sorts of information. Some of this information is COBie required, and some of this information is not COBie required. And from a designer point of view, we should really be concerned about if it's COBie or not COBie. It's just information that is relevant and appropriate for the client use later on. That means that we need to have our software and our processes set up to be able to output this type of information by default. So when we get the question to include COBie information in the output or not, we don't have to think about it. We just output standard data, and the information is mostly relevant. There might be a couple of tweaks we need to do when we setting up the new project, but 95-98% chance is that we're going to have all the information covered by default. And each design practice then need to have a responsibility matrix that is listed according to what the software can output, all the components and all relevant information that comes out in the schedules. The information we issue at each project stage need to be suitable for what the intended use is. So if we issue a 3D model, it might be intended for clash detection. That means that the information in that 3D model have to be set up and functional for that type of purpose. And that should then be listed in the BIM execution plan, in the responsibility matrix, what type of information is required for each stage and what it needs to be used for. And we then need to have a clash detection process where we're saying this type of information is going to be clashed at this project stage, and this type of information is going to be clashed at another part of the project stage. Then we have the setup of the software. It's common that a design team starts in 2D or SketchUp and to get some sort of design ideas down on screen or on paper. And then that work is then usually aborted to move into a 3D platform like Revit. The best advice is to try to address the software use at an earlier stage of the project, so we don't have to spend time doing work that we then can't use moving forward. We have to start all from scratch again and maybe convert into DWG and link DWGs and redraw the building in 3D. Not only is that wasting time, but it's also introducing errors into the project. If we can start earlier in a platform like Formit or using Rhino, for example, is a good solution to transition information into Revit, then we have less risk of errors on the project, and we can use existing information that we start at early stage and develop that type of information to suitable information for each project stage. So it's kind of a progressive development rather than coming up to a halt abort, and restart. So when planning a project, it's important to include factors like what the client wants, when the client needs something, what the design team want, how we're going to produce the information, and how the information is going to be used once the building is up and running in operation. Other than just thinking of planning deliverables as 2D information on drawing sheets for construction, or 3D information for clash detection, or for just learning how to use 3D on a project. It needs to be more purpose, and it needs to be planned more carefully than that.